They're asking us for zeros, which means they're asking us for numbers you could plug in for x that would make this equal 0. So graphically, that looks something like this. The x values where we plug it in and we get y equals 0. Okay, so there's a trick to do that without having to rely on technology. It's called the Rational Zeros Theorem. And the Rational Zeros Theorem looks like this. You write out the list of the factors of the last number in descent and when you have your polynomial in standard form. So I'm looking at that negative 14. Plus or minus 1 is a factor of 14, because 14 divided by 1 or negative 1 comes out to be an integer. Plus or minus 2, plus or minus not 3, not 4, not 5, not 6, but 7, and plus or minus 14. Those are all numbers that we can divide 14 by and get non-decimal numbers as a result. Now, you divide that, I shouldn't say you divide that. You compare those to all the factors of your leading coefficient. So I'm looking at that 3. Positive negative 1 can divide evenly into 3. Positive negative 3 can divide evenly into negative 3. Okay? So the Rational Zeros Theorem tells you every possible combination of the numerator divided by the denominator is a possible rational zero. So here, I'm going to list them all out for you. I could have positive 1 in the numerator, positive 1 in the denominator. 1 divided by 1 would make 1, right? Or I could have negative 1 in the numerator and positive 1 in the denominator. Negative 1 divided by 1 would make negative 1. I could have positive 2 in the numerator, and see how I'm keeping it fixed as positive 1, and I'm going to go back over and do it for negative 1, and then go back and do it for positive 3 and negative 3, because there's a ton of these, so we got to have a strategy so we don't get lost. So I'm thinking about positive 2 divided by positive 1, negative 2 divided by positive 1. Positive 7 divided by positive 1, that's 7. Negative 7 divided by positive 1, that's negative 7. Positive 14 divided by 1, negative 14 divided by 1. Okay, so I've compared every possible top number with positive 1. Now I need to go back and do it again for negative 1. So positive 1 divided by negative 1 makes negative 1, but I'm not going to write that one down because we've already got that in our list. Okay? And then if I do negative 1 divided by negative 1, I get positive 1. That's another redundant 0, so we don't need to write that down. So 2 divided by positive 1 makes 2. We've got that one. 2 divided by negative 2 divided by negative 1 makes positive 2. Sorry, that's this one. Positive 7 divided by negative 1 is negative 7. Negative 7 divided by negative 1 is positive 7. So we've got all those ones. 1 divided by 1, 2 divided by 1, 7 divided by 1. We've taken care of those. 3 is going to be the unique ones. Okay? So how about positive 1 divided by positive 3? We don't have that in our list. How about negative 1 divided by positive 3? We don't have that in our list. How about positive 2 divided by negative 3? We don't have that yet. And how about negative 2 divided by, oh wait, I went in reverse order. I'm keeping this as, I'm thinking about just positive 3 in the bottom. So 2 divided by 3 is 2/3. Negative 2 divided by 3 is negative 2/3. 7 divided by 3 is 7/3. Negative 7 divided by 3 is negative 7/3. 14 divided by 3 is 14/3. Negative 14 divided by 3 is negative 14/3. Okay, and then you'd want to go through the list one last time, comparing the top numbers, dividing them by negative 3, but that's just switching the sign, right? So you'd get the same numbers that we already have in this list. So this is the full list of possible rational zeros. Everything else, any other solution must be irrational. It's a huge list, right? Which is why having technology is great, because we don't bother with this stuff most of the time anymore. But we do need to know how to do this depending on what you study in mathematics in the future. So we don't know which ones are zeros, though. That's the crappy thing, is you got to plug in 1, see if it works out. If I plug in 1 in for x, 1 to the third is 1. 3 times 1 is 3. So that's 3 minus 7 is negative 4. Negative 4 plus 6 is 2. 2 minus 4. I plugged in 1. I didn't get 0. So let's move on to the next one. That's not going to be a 0 for this problem. Okay. Negative 1, if I plug that in, that's going to make negative 1 to the third is negative 1. Negative 1 times 3 is negative 3. This is negative 7. Did I do that right last time? I think I did. And if I plug in negative 1 here, I get negative 6, and then negative 14, that's negative 20. That's far off from being 0. So that one also doesn't work as a 0. So what if I plug in 2? 2 to the third is 8. 8 times 3 is 24. 2 to the second is 4. 7 times 4 is 28. 6 times 2 is 12. And minus 14. Do we have a winner here? No, I don't think so. 24 minus 28 plus 12 minus 14. Not quite. So I tried that, didn't work. Let's plug in negative 2. Negative 2 to the third is negative 8. Negative 8 times 3. I'll show you why this is going to be easier in just a second. You actually don't have to go through the whole list. Once we find one of them, it makes it much easier. Okay, I'm plugging in negative 2. That's 28. That's not going to work. That's far off. Okay, so forget about that one. Let's plug in 7. 7 to the third, some huge number. 1029 minus 7. That's going to be 7 to the third again, right? Because 7 times 7 squared. And then 7 times 6. This isn't going to work either. 42 minus the 14. That doesn't make 0, so this doesn't work. And negative 7, I can tell you right now, is not going to work because it's going to give you negative 1029. That's still minus. That's far off. Maybe 14. These numbers are huge. The first term is 8,232. I think I just picked a really bad problem to do. I was hoping I could get right to the next step. 448. That's not going to work. Oh wait, I'm doing the wrong one. I did 7, so it's supposed to be, or maybe I did it right. I did that. No, that's 1,372. You can fall asleep right now. All I'm doing is I'm plugging in 14 into the original equation. That's not going to work. That's not a 0. Okay. It's probably going to be one of the fractions. So it depends on your teacher. For my classes, I don't know who's watching my video, but for my classes, I'm going to give a quick little sketch of a graph to help you so that you're not just wasting your youth away doing this stuff. Look, this is the graph of the original function. I'm not going to give you what the exact zeros are, but I'll give you a sketch of the graph, because if you look at the graph, you can see that it seems to cross a little bit above 2. So that gives us a hint as to what our 0 is going to be. Okay, look, I plugged it in Desmos, and I found it's a number where it crosses a little above 2. And I have a number on my list that's a little above 2. How about 14 thirds? That's a little bit bigger than 2. No, sorry, 7 thirds. That one's too big. That's closer to 5. 7 thirds. That's 2.33. That looks like what it was on our graph, right? So let's put 7 thirds into this original function. And then 7 thirds to the third power. That's going to be 7 to the third power in the numerator, so that's 343. But in the denominator, it's 3 to the third times 3. One of those 3's will cancel out, so it's going to make 9 in the denominator when you simplify that fraction. So minus 7 times 7 squared is 49. 3 squared is 9. And then here, that's 42 over 3. Okay, I think it's going to work out, because this is 343 over 9 minus, what is that? That's 49 times 7. That's 343 over 9. Oh! Is that 14? Is that 14? So I think we found the end to this, just part of the problem. Yeah, that's 14. So this subtracted by this is 0. So we plugged in 7 thirds and we finally found our 0. So 7 thirds is a 0. Okay? Determine which one of these are zeros. I just found the only rational 0, unless this graph crosses somewhere else. And it does not. Okay? So that's it for this problem. You can, if you're in my class, you can use Desmos to help you spot them. Okay? That way you don't keep plugging in a bunch of numbers like I did at the beginning. You can narrow it down, like, okay, I saw on the graph it crossed near 2, so 7 thirds must be it. Okay, that's it for this question. But what you would do to find out all the other possible rational zeros is you would divide this by x minus 7 thirds and write out what's left. you will find that there's no remainder. I'll show you what to do for that question when it comes up later.